Okay, so hi everyone. Today I'm going to show you how to factorize by completing the square. So we're looking at a quadratic in the form of ax squared plus bx plus c. And in order to factorize by completing the square, we need to add the value of b over 2 all squared. But we also need to subtract that as well, b over 2 all squared, in order to balance the equation. So I've got two examples. I'm just going to go through. One you can fully factorize, and one you won't be able to, and we'll see the difference between those two and how you can and how you can't, and the reasons as to why. So this first example, I have x squared take 8x take 3 in the form of ax squared plus bx plus c. The value of a is positive 1, the value of b is negative 8, and the value of c is negative 3. So what I need to do here is add, as I said, b over 2 all squared, and also subtract b over 2 all squared to balance it just after this bx term, but before the constant term here. So I'm going to rewrite this expression, x squared, take 8x, but I'm going to add in here plus the value of b over 2 all squared. So the value of b we said was negative 8 over 2 all squared. Like I said, I need to subtract that as well. So take that same value, okay, and the constant term remains the same, minus 3. Okay, so we can actually solve what's in those brackets there. So x squared remains the same, minus 8x. So minus 8 over 2 is minus 8 divided by 2, which is 4. 4 squared is 16, so add 16. Okay, minus 4 squared, remember, is minus 4 times minus 4, which gives us the positive 16. And obviously we're going to subtract the same, 16, take 3. Okay, now the reason we've done this is to create a perfect square. So this, these first three terms in this expression now, I can factorize into a perfect square. So x squared take 8x plus 16 can be factorized, if you remember back to factorizing perfect squares, can be factorized to x take 4 all squared. Or if you look at it in terms of sum product, you know, two numbers that add to give you minus 8 and multiply to give you positive 16. Okay, and then we're also left with negative 16 take 3, which is negative 19. Right, now to complete the factorization here, I'm just going to move this up a bit. Remembering back to the difference of perfect squares, so essentially we've got two parts to this equation, or two terms. The first term, x take 4 all squared, is a square term. It's x take 4 times by x take 4. And the second term here is 19, which is not a square term, but we can use difference of perfect squares using surds as a factorization, because it is separated by a subtraction sign. Because it's separated by a subtraction sign, we can use that difference of perfect squares. Subtraction obviously meaning difference. Okay, so I'll have to set up my two sets of brackets, remembering factorizing difference of perfect squares. That first, the square root of that first term goes at the front here, so x take 4, x take 4. Now, although 19 isn't a square term, we can write it as square root 19. And in between those terms inside the bracket, one is obviously a plus and one is a minus. Okay, I'm going to go through another example. So that's, fully factorized by completing the square. I'm going to go through another example here, which is slightly different, and we'll see why. So what we're going to do again is we're going to add b over 2 all squared, take b over 2 all squared after the bx term here. So I'm going to rewrite this with x squared plus 2x. In this case, the value of b in this expression is positive 2. So I'm going to write 2 over 2 all squared. So that's plus. I'm also going to subtract that, 2 over 2 all squared. And also we keep that constant term at the end, plus 8. So if I'm looking at those brackets there, 2 over 2 all squared, 2 divided by 2 is 1, 1 squared, still 1, so plus 1. And I'm going to do take 2 over 2, which is 1, 1 squared is 1, and plus 8. Okay, here we have this perfect square, so two numbers that add to give us 2, multiply to give us 1, that number is 1, so it's x plus 1 all squared. Then I've got minus 1 plus 8. So minus 1 plus 8 is positive 7. And we sort of need to stop there because at this point we actually can't factorize it using a difference of perfect squares. Notice in this first example we had a subtraction sign between these two terms, difference of perfect squares, and in this case it was using surds. Here there's not a difference of those two terms, it's an addition sign. So we can't actually fully factorize, or we can't factorize that any further, we have to stop there. And in terms of when we get to looking at parabolas, yes, we can look at this and say the vertex is at -1, +7. But we can also determine there are no x-intercepts because we can't factorize it using difference of perfect squares. This one here, there are 2 x-intercepts, and we'll look at that in a later example, how to actually determine that using the null factor law. Okay guys, thanks for watching.